Hi everyone. So I decided that I would make a little video showing how to work out some of the problems from our heat exchange worksheet. I'm going to take a look at a couple of them. So I'm going to start with number 7. Number 7 says, suppose 1 mole of water evaporates in 1 day. How many water molecules on average leave the liquid each second? So to start that problem, first we need to get how many molecules there are in 1 day. So if we have 1 mole per day, which is what we were given, we can convert that to molecules because 1 mole has our favorite number, 6.02 times 10 to the 23rd molecules. And that gives us 6.02 times 10 to the 23rd molecules per day. Alright, so now we have to find out how many seconds there are in a day. So we start with our 1 day. There's 24 hours in 1 day, 60 minutes in every hour, and 60 seconds in 1 minute. And that's going to give us 86,400 seconds in a day. Alright, so once we have that information, all we have to do is divide our molecules by our seconds. So we get 6.02 times 10 to the 23rd molecules divided by 86,400 seconds, and it puts nearly no dent in it. We have 6.97 times 10 to the 18th molecules evaporating every second. Alright, so that was probably a pretty easy one for you. It's bringing back a little bit of your Unit 1 conversions. So next one I'd like to look at would be number 9. So it says a copper ball with a mass of 1650 grams is heated to 900 degrees Celsius and then placed quickly on a block of ice that weighs 5,000 grams and is at 0 degrees Celsius. The copper cools completely and there is still ice left. How many grams of ice will be left over? So this one is a fairly intensive problem. So we have number 9. For heat exchange problems, I like to write what information I have for each one. So I have 1650 grams of copper, and then it's heated to 900 degrees Celsius. Its final temperature is going to be 0 degrees Celsius because it says it cools all the way and there's still ice left. And the second part of the problem, the ice weighs 5,000 grams. And we have that at 0 degrees Celsius. And it wants to know how much ice will be left over. Alright, so once we get that, we can start. So we can find out Q for the ice. So we need to find out how much energy it would take to melt all of this ice. So how much energy would it take to melt all of that ice? So because we're just melting it, we're going to use our N delta H. And that's going to be 5,000 grams divided by 18 grams. That gives us our moles. Times 6.02 kilojoules per mole. So that's the molar heat of melting. And that equals 1,672 kilojoules, or 1,672,222 joules to melt all that ice. So once we have that, We just need the second part of the puzzle. So now we can figure out how much energy the copper is going to be able to release. So we have our Q equals mc delta T, because there's no phase change for it. 1650 grams is our mass. If you look on your reference chart, the specific heat in joules for copper is 0.389 joules per grams degree Celsius. And our final temperature is 0. Our initial was 900. So the copper is going to give us negative 577,665 joules. So that's how much energy that copper has. Now, if I take it, I can solve for the mass, the moles of water that much can melt. So if I take 577.665 kilojoules, so I just converted this to kilojoules because we're going to use our Q equals N delta T, because I got to get mass. I got to get the mass that this would melt. So I have moles of water is what I'm looking for, and 6.02 kilojoules per mole. So the molar heat of melting for water. And the reason this is positive, remember whatever this copper loses, this is what is going to absorb it. So it's going to be positive. So if you get that, you get 95 moles of water is what that amount of energy can melt. Now we just need to figure out how many moles we had to start. So our 5,000 grams divided by 18 is going to give us 277.8 moles. And we can subtract our 95. That gives us 182.8 moles that weren't melted. And we can take that and convert it to grams, and we get 3,290 grams of ice left. So first we had to find how much energy it would take to get all of the ice melted. Then we had to find out how much energy the copper had to melt the ice. And then we used the opposite of that energy to solve for moles of water. And then we were able to get moles of what we started with, subtract what we calculated, and then just convert to grams. Alright, so next, I think the last one I'll do right now, we'll do number 13. So 13 says one piece of copper jewelry at 105 degrees Celsius has exactly twice the mass of another piece of copper jewelry at 45 degrees Celsius. If the pieces are placed in contact, what will the final temperature be? So this one is a little tricky. The first thing I'm going to do is write my givens. So I have 105 degrees Celsius and my mass is 2x grams of copper. I'm going to convert that to 2 times mass. And we have 45 degrees Celsius copper, and it's just going to be M copper. Now, to set it up, the one that is hotter, so the one that has a higher temperature, is going to be the one that we're going to put in the negative bracket. So I'm going to put the 2M for the mass. If you look on your reference sheet, copper is 0.389 joules per grams degree Celsius. and we don't know the final temperature, and we started at 105. Now that's going to equal just the mass of the other one, and 0.389 joules per gram degree Celsius. And then we have x minus 45 degrees Celsius. So you may be wondering, what are we going to be doing with m and x? Well, this is 2 times the mass. The mass is in grams. So we can actually cancel out that grams with that grams, and this grams with this grams. And now we're just left with 2. So we have 2 times our 0.389, which is going to give us, when we distribute it, so we're going to multiply these together and then distribute them accordingly. So we get negative 0.778x plus, because sign changes, negative times negative, plus 81.69. And that's going to equal 0.389x minus 17.5. We can add this to get everything on one side, and add our 17.5 to get it over here. Just some algebra. And essentially what you're going to end up with is 99.19 divided by 1.167. And that's supposed to be 1.167 x, and that's why we divided by that. So we're going to get x equals 85 degrees Celsius. I know it's a little skipping some parts, but it's just algebra. So if you get this set up and understand that you can just cancel out these grams, then you are good to go. So I think I'll leave it here for now. Hopefully this was helpful, and I will see you later.